Hi guys, let me take a few minutes and set up the situation for the birthday problem here in this first video. So let's assume that there are 23 students in a class. How likely is it that at least one pair of individuals shares the same birth date? So we mean month and day out of those 23. So this is the probability that we want. Notice it's an at least one probability. At least one pair of individuals shares the same birth date. Remember that the complement of at least one is none. So we can think of this probability as 1 minus the probability that there are no pairs of individuals that share the same birth date. But for that to be the case, everyone must have their own unique birth date. So we can calculate the probability here in number 2 by looking at 1 minus the likelihood that every individual, starting with the first individual, then the second individual, all the way to the 23rd individual, they all have their own birth dates. So notice, for the first person, there are 365 possible birth dates, and for that first individual, there are still 365, if you will, that we want. That first person can have any birth date that they like. Now, in order for the second person to have a different birth date, again, all 365 remain possible for that second person. I haven't taken a birth date out of what is possible. You can be born on any day that you like. But the idea is, what do I want? I only want any of the birth dates that have not already been taken by someone. So now there are 364 that are available. There are 364 that are available to be what you want if all of the birth dates are to be different. So following this same pattern for the third person, again, they can be born on any day, but the truth is I only have now 363 that are available. So see if you can continue writing out all of these fractions that we would have to multiply together. So we have a likelihood for the fourth person and for the fifth person. This ellipsis represents that we're going to multiply in there by the sixth, the seventh, the eighth, the ninth to 10th person's probability, all the way down to the 23rd person's probability. So see if you can count down and actually fill in all of those probabilities all the way down to the 23rd person. So we could evaluate this expression to get the exact answer. The problem is it would be incredibly tedious to put that into your calculator, and depending how you put it in, you might even get an overflow error because you're going to get such large values in both the numerator and the denominator. So this is a question that is ripe for using simulation. A simulation is a great way to try and evaluate what this probability might be. So, first of all, we want to simulate a class of 23 individuals, and we need to assign every individual in there randomly a birth date. So we are making the assumption that birth dates are assigned randomly amongst the different individuals. So 23 individuals have to have birth dates selected for them. So the 23 goes third. That's the third argument in the random integer command. So I would offer the simplest way to do this. The simplest way to do this is to assign birth dates 1 to 365. So literally what this command will do, it will generate 23 random integers. Those integers will be between 1 and 365, and it can include the 1 and the 365. So we're going to put those into list 1, and then we're going to sort this list ascending. So sort A, that is sort ascending. So what we would have to do then is press the stat button and press the enter button after executing this command. All of the numbers are going to be sorted in order. So what we're going to have to look for are consecutive numbers that match. So the numbers will be in order if there are two numbers that match, if you find at least one pair. At least one pair of two numbers that match. If that is found, then the simulation represents a random sample of 23 individuals where, indeed, at least one pair of individuals share a birth date. If no pairs are found, then you have to decide what that simulation represents. Again, a random sample of 23 individuals where something else occurs. So either this will occur or something else will occur. So see if you can describe, I would offer if you look up higher in the handout, it might be pretty easy to describe this. See if you can describe this event that's represented if no pairs of numbers are found in list 1. So there are some issues with this, though. Understand, if you want to repeat this simulation multiple times, you're going to have to keep executing this command. You're going to have to look through the list manually over and over again to see if you find pairs of numbers, and that becomes a little tedious. So what I'm going to have you do is write a simple computer program that will actually allow you to make that comparison automatically with the push of a button.